CVE150.2 Engineering Graphics. Module 5 Orthographic Projection. So for this lesson, we will be discussing what is orthographic projection and study the steps in making an orthographic projection. So by the end of this module, you should be able to understand the process in making an orthographic projection of a certain object, and also be able to draw an orthographic projection of a certain object. So representational drawings and sketching is concerned with drawing what you see and drawing that which you imagine as if you actually saw it. And technical drawing is concerned with representing objects according to conventions that allow size, proportions, and structure, as well as appearance, to be precisely specified. So that is yung engineering drawing natin. That is technical drawing. So the common aspect between these two types of drawing is the most fundamental concept involved is the geometry of projection. So either of the two, whatever you draw, you always use the concept of projection. So consider an object, say a house here, enclosed in an imaginary glass box. So this is the glass box. Positioned such that the panes of glass are parallel to the major surfaces of the object and at 90 degrees to each other. So it should be facing parallel. So yung front ng bahay is parallel to sa side ng glass na to. So if one projects lines from the corners of the object, with each line at 90 degrees to a surface, of course, of the glass, until these lines intersect to the glass, one can lay 6 views, each of which represents the object as it is seen with the various panes of glass. So if you were to project the faces of the object to the imaginary glass, so you will create 6 views. So that is the front view, right side view, back view or rear view, left side view, top view, and yung bottom view. So having projected the respective views of each face of the object onto the glass surfaces, we can unfold the glass box. So we will unfold that box until all the views are laid out in the same plane as the front view. So this is now the structure nung laid out surface nung glass box. So you notice that each view can see and show only one aspect of the object. So this part, you can see the back view. Here is the left side view, top view, front view, bottom view, and the right side view. And that all the views are aligned to one another because of the unfolding of the imaginary glass box. So this is the orthographic views of the object, say yung house. So this process uses principles of orthographic projection or yung true drawing. Now, before we proceed to the definition of orthographic projection, so in general, orthographic projection is under graphical projections. So graphical projections is divided into two types. This is parallel or axonometric, and the second is perspective. So perspective has different types also. So you have 1-point perspective, 2-point perspective, and 3-point perspective. So we will discuss perspective in the following module. So parallel projections. Under parallel projections are orthographic projection and oblique projection. So orthographic projection has primary or yung multi-view and auxiliary. So auxiliary are 3D like image nung drawing. So they are reversible. So from a 3D or from an isometric, you can create a orthographic projection, first angle orthographic projection, and from the first angle, you can also create an isometric. So yan yung um, uh, types ng mga projections. Now, orthographic projection is a means of representing three-dimensional objects into two dimensions. So, as you have seen kanina, from 3D, naging 2D siya by showing its views on different side of the object or different faces of the object. So, it is a form of parallel projection in which all the projection lines are orthogonal to the projection plane, resulting in every plane of the scene appearing in affine transformation on the viewing surface. So there are 6 principal views of an orthographic projection. So these are the front, top, right side, left side, back side, and bottom view. So for a standard technical drawing, the minimum or the standard drawings or orthographic projection of a certain object, you can only show your top view, front view, and right side view. So by showing only these 3 views, it is enough to define or depict the detail of a certain object. But in the case of drawing plans or making building plans, we will utilize 5 views. So that is top view, yung front view, left side view, back view, and the right side. So these 4 views here are the elevations, and there is the floor plan. If this is a building plan or residential plan. So that is the principal views of an orthographic projection. So what are the steps in creating an orthographic projection? So first is, if you have an object here, so say we have a object here, this one. So first is you choose which is your front view. So usually you will choose the side where it shows greater detail of the object. So probably we will use this view as our front view since it shows greater detail compared dito na side. So if dito na side, it only shows a rectangular shape, but here we can see they somehow see the shape of the object. So in the case we only need 2 views, so there's for simple objects you can show 2 views only, especially sa mga symmetrical na object. But we will for this example we will draw 3 views for illustrative purposes. So next is draw the visible features of the front view. So say meron kang mga dimensions here, so you can draw this using this dimension. So this is how the front view looks like. So next is you will draw vertical projectors and horizontal projectors. So this is will serve as your guide para even yung equal yung measurements mo in projecting your top view and your right side view. So next is you will draw the top view. So this is the top view. So you will use here the alphabet of lines. So since this part is hidden from top view, so you will use hidden line. Then this part here is we will projecting it doon sa front view. So this is also a hidden line since it is not actually seen in the front view. So next is you will draw a 45 degrees here so that you can project the this side of the top view doon sa right side. Since this measurement here is the measurement of your right side view. So using these projected lines or guidelines, you can now draw your right side view. So this is your hidden lines, and then project back from the right side view if needed. So but in this case we will not use any projection from the front view or the top view. So this is the right side view, how the right side view looks like. Now you will now add the, since the object has a circle, so it is needed to put a center line. So these are the center lines here and here. So this view are adjacent, and this measurement here is equal dito. So this is an rated view. So that is the complete orthographic projection of an object. So that is how you draw orthographic projection. So top view, front view, and right side view. That's all for this lesson, and that ends our module 5. So thank you for listening and have a good day.